Group data, it could be given data sets as follows. You may have 7, 6, 4, 3, 4, 9. Okay, so you'll be asked to find measures of central tendency and dispersion. Measures of central tendency and dispersion. So in this case, you will need to calculate for each of these ones here. So the first thing you need to do is rearrange the data in ascending order. Rearrange the data in ascending order. So what's the smallest figure here? We have 3, we have a 4, we have a 4, we have a 6, we have a 7, we have a 9. So these ones have already been rearranged now in ascending order. Okay. So we now need to square these values. So 3 squared, we have 9. 4 squared, 16. 4 squared, 16. 36, 49, and 81. The total of this is called summation of x. The total of this is called summation of x squared. And how many there are? 1, 2, 3, 4, 5, 6 is called our sample size n. So let's add. So we have 3 plus 4 plus 4 plus 6 plus 7 plus 9. So the total we're going to get here is 33. That is our 33. When we add the square totals here, the total we're going to get is 207. Then our sample size is 6. So this is ungrouped data. So the formulas are different from those ones in grouped data. So I just need you to master just 5 formulas. The mean, which is the average, is given by summation of x over n. The variance, the summation of x squared minus summation of x to the power 2 over n. Everything over n minus 1. This is called a sample variance. Then standard deviation is simply when we square root the what? The variance. The coefficient of variation is simply the same. And standard deviation divided by mean over 100 times 100. So this is how we do it in ungrouped data. But for grouped data, there's some difference. So this is ungrouped, and this is grouped. So for grouped data, the mean has a frequency aspect. So summation of fx over n. We're just putting an f somewhere. The variance, summation of fx squared minus summation of fx to the power 2 over n, everything over n minus 1. The standard deviation is the same. The coefficient of variation is the same. So we just want to get it from this part now here. So what is the formula for the mean? Summation of x over n. Our mean is 33 divided by 6. So when we calculate that, we're going to get 5.5. All right. Our variance simply given by summation of x squared minus summation of x to the power 2 over n, everything over n minus 1. So this is 207 minus 33 squared over the n is 6 divided by 6 minus 1. So if you calculate your answer very well, you're going to find your variance as 5.1. But you need to be methodical. Follow it step by step. Start from here. 33 squared over 6. So here we're looking at the variance. We're still using this data set. Okay. What data set do we have? 34, 46, 34, 46, 34, 46. 79. 34, 46, 79. Okay. So these are the values that we are considering. So we had our summation of x squared, summation of x, and our n. Our n was 6. Our summation of x squared was 207. And our summation of x was 33. How do you define the mean? Who remembers? The mean, how do you define it? The mean is simply what? Summation of x over n. 33 over 6, which is 5.5. How do we find the variance? Summation of x squared minus summation of x to the power 2 over n, everything over n minus 1. So this is 207 minus the 3 squared over 6, everything over 6 minus 1. So the 3 squared divided by 6 gives us just this part here. You do it separately. It will give you 181.5. So 207 minus that answer will give you 25.5. When you divide this by 5, our variance therefore got 5.1. Then our standard deviation is simply when you square root the variance. So square root of 5 we get 2.258. So our coefficient of variation, I said, is the same, where our standard deviation over the mean times 100 in percentage, if you want, will be 2.258 divided by the mean, which we found as 5.5 times 100. This one will give us 41%. 41.1%. Then we also have what is called the coefficient of skewness. Skewness looks at how bending the distribution is. If it's bending to the right, it looks like this. If it's bending to the right, left, it looks like this. If it's normally distributed, it is normal like this in the middle. So it is given by a single formula. Skewness is simply 3 times median over standard deviation. So now we need to understand how to find the two remaining things, the median and the mode. So the mode is easy. The mode is the most frequent. And which number appears the most here? The number that appears the most is the 4. So mode is what? Is the 4. The median and the quartiles are a little bit delicate. So those ones groups, answer them separately. So let me answer the 5 remaining parts. The range is simply the difference between the highest number and the smallest number. So our highest number in this case is 9, and the smallest number is 3. Our range is 6. Our mid-range is the average of the two extremes, 9 plus 3, which is 12 divided by 2, we get 6. And the mode, the most frequent. You can have a bimodal frequency or a mono. So here our most frequent number is 4. It's appearing twice. That is our mode. If all of them are the same, then we say there's no mode at all. So they're all appearing once. Then we go to the quartiles. So we have what we call the first quartile, simply a quarter of n. Some books say n plus 1. It's the same thing. Quartile 2, which is the median, it is half of n. Quartile 3, which is 3/4 of n. So here the rules of engagement as follows. If you find a number which is a decimal, for instance, 2.1, don't pick 2, you pick the third number. Even if it's 2.9, as long as it's a decimal point, you pick the next number. So it's easy when there's a decimal. But if you pick a whole number like 2, it means you're getting the second number and the third number divided by 2. If you pick a 4, it means the fourth number and the fifth number divided by what? By 2. These are the rules under which this formula is. But if you have n plus 1 here, you round off to the nearest number. If it's 4.5, you get the equidistant 4 and the fifth divided by 2. But that's not what I'm using for now. So let's look at our n here. Our n was what? 6. So here, what is a quarter of 6? What is half of 6? What is 3/4 of 6? So a quarter of 6, in this case, is giving us 1.5. That is decimal. It means our Q1 is the second value after rearranging it. So in this case, our Q1 is what? 4. 4. Value 4. 2 is a position. Here, half of 6 is what? 3. So since it's 3 here, we're going to get the third number and the fourth number. We divide by what? By 2. So 1, 2, 3, 4. So these two, we average them. So 4 plus 6 is 10, divided by 2 is 5. So Q2, which is also the median, is giving us a 5. And Q3, 3/4 of what? Of 6. 3/4 of 6 gives us 4.5. 4.5 has a decimal, so this means we're picking the fifth number. As long as the decimal, you round up, not rounding off. So this Q2 is the average. So 1, 2, 3, 4, 5. Q3 is 7. All right. So now we want to relate these two guys here. So the difference between the third quartile and the first quartile is called the interquartile range. So Q3 minus Q1, 7 minus 4, what we get is a 3. So this is called our interquartile range. Are we moving together? So this brings us to a special box which we call the box whisker plot. It has 5 key elements: the minimum value of x, the maximum value of x, and the 3 quartiles Q1, Q2, and Q3. So according to our diagram here, 3 and 9 were our minimum and maximum respectively. In Q1, Q2, and Q3, we had what? 4, 5, 7. 4, 5, 7. The distance from here to here is a 1. Distance from here to here is a 2. So where there's a larger figure, that's where we say it is skewed to the right. So it is skewed to the right. So the distance from the lower quartile, the upper quartile is called the interquartile range. So IQR was what? 7 minus what? 4, we get a 3. So we need to find the minimum value, which we have Q1 minus 1.5 IQR. We'll find the coordinates. So Q1 is what? 4 minus 1.5 is the standard figure, but the interquartile range here we found as 3. So 1.5 times 3, we get 4.5. So this, in this case, is called the correction term, 4.5. So 4 minus 4.5, we get negative 0.5, which is somewhere here, negative 0.5. So we get the lower extreme value. Upper extreme value, we simply do what? Q3, the sign changes here now, plus 1.5 IQR. Where is the 1.5 coming from? I say the standard value. So what was the upper quartile? 7. That's 1.5 IQR. So this still gives us a 4.5, which is our correction term. So 7.5, 7 plus 4.5, we get 11.5. Somewhere here. So between 0.5 and 11.5, if there are any values outside that, they're called outliers. So here, the 3 is within and the 9 maximum value is within. So here we have no outliers. So this gives us a picture of how to deal with outliers. Outliers really in data research are used to identify and sort information that has extreme values that are out. You have 7 girls and 1 boy. The boy is an outlier. You have data. You are trying to find out the mean average age you enroll for a school pupil in grade 1. Teachers are saying 7, 8, 9, and one of them is saying 15. So 15 is an outlier. So outliers really are important in the sense that we may use them to sort out information that may be out of context. So this is how ungrouped data is dealt with. Unless there are any questions, I will send you homework for class just based on these 2 important aspects that we have dealt with.